Hello everyone. This is part 3 of 5 lecture series of language models. If you have not watched my previous videos on introduction to language model and the types of language model, please go and watch those series. So in this lecture we are going to talk about how to process text using language models. So basically, machine learning models cannot process raw text. As you understand, we need a mechanism to convert text into numerical form. Quite common approaches to vectorize the text data are one-hot encoding and integer encoding. So vectorization simply means that array of numbers as input. So let us discuss first about one-hot encoding approach for text representation. So one hot encoding technique encodes each word in the vocabulary. So this means that so one hot encoding technique encodes each word in the vocabulary. So when you talk about vocabulary, so vocabulary is nothing but simply unique words in your data set of sentences. To achieve this representation, what we do is create a zero vector with length equal to vocabulary size and then place the 1 in the index that correspond to the word. As shown in this diagram, you can see here. So here are the words such as I ate an apple and played the piano. So these are 8 words, and for each word we place 1 at that particular index, and all other places we place 0. So this kind of representation is known as one-hot encoding. So uh, so basically there is limitation of this approach. The limitation of this approach is that it creates a sparse vector. So i.e., it has only one non-zero element and all other elements are zero. So as the size of vocabulary becomes larger, the representation for even small sentence requires the space up to the size of vocabulary. So this become computationally too expensive. Next limitation is that it cannot capture semantic information. So this means that it cannot represent the relationship between two words or two sentences. So we will learn about this on later stages. In case of a natural language task, each word represents a single feature. So it cannot capture relationship between similarity of any two as well as similarity of their encoding. So feature weight combination is not meaningful here. So because of these limitations, so we need a word embedding technique basically to overcome the limitations imposed by one-hot encoding and integer encoding approaches. Word embedding technique arise. As you know, human can easily understand the relationship between words or sentences such as king and queen, but for computer to understand this task is not simple. A human can understand the relationships such as king and queen, man and woman, and so on. But the question is how computers can figure it out. Easy answer to this question is word embedding. So word embedding is a type of word representation that enables us to figure out the relationship between the two words or sentences like human. So how does the word embedding represent this information? Question is that. So the word embedding represent this information by learning the representation of these words in an n-dimensional space. For example, you can see here an embedding vector for words such as cat, mat, and on, which is represented by 4 dimensions. So in this way, using embedding, words that are similar or closely related have the similar vector outputs, and distinct words are remotely located in the vector space. So that means to say that if there is cat and if there is something like kitten, if there is cat and kitten, then here what it will output is, here the output would be like 1.2 minus 0.1 4.3, and maybe this value will be around 3.1 or something around that, little bit of change only. So cat and kitten, so that it can identify and distinguish that cat and kitten are more closely related than other ones. Thus, using word embeddings, all individual words are represented as a real valued vector in a predefined vector space. Each word is mapped to one vector. These words are automatically learned during training. These are the training parameters. Actually, these words and the learning of these vectors is actually the training parameter. Or actually we can say that these are the weights learned via model. Weight values. Cat has some particular weight vector, mat has some particular weight vector, on has some particular mat vector, and so on. So also we can say that using word embedding technique, we can have certain operations. Vector operations, like vector differences between a pair of words can be added to another word to find similar vector. For example, man minus woman plus queen is similar to king. Man minus woman plus queen. So man minus woman plus queen is similar to king. So minus woman and plus queen almost cancel out, so man equal to king. So this is kind of similarity or similar vectors we can obtain using word embedding technique.